Parallel lines. Non-intersecting coplanar lines are called parallel lines. Transversal line. Line intersecting coplanar lines is called transversal line. When a transversal intersects a given line, 4 angles are formed at the point of intersection. Similarly, when a transversal intersects 2 given lines, 8 angles are formed at 2 points of intersection. If 2 parallel lines, line L and line M, is intersected by a transversal line EF, then we get 4 equal pairs of vertically opposite angles. Angle APE is equal to angle BPQ. Angle BPE is equal to angle APQ. Angle CQF is equal to angle DQP. Angle CQP is equal to angle DQF. 2 equal pairs of alternate angles. Angle APQ is equal to angle DQP. Angle BPQ is equal to angle CQP. 4 equal pairs of corresponding angles. Angle APE is equal to angle CQP. Angle BPE is equal to angle DQP. Angle APQ is equal to angle CQF. Angle BPQ is equal to angle DQF. 2 pairs of interior supplementary angles which are situated one side of the transversal. Angle APQ plus angle CQP is equal to 180 degrees. Angle BPQ plus angle DQP is equal to 180 degrees. Theorem 1.2. If a pair of alternate angles formed by a transversal of 2 coplanar lines is called congruent, then the lines are parallel. It is given that transversal EF intersects 2 coplanar lines L and line M in points P and Q respectively, and angle APQ is congruent to angle PQD. We have to prove line L is parallel to line M. Proof. Suppose line L is not parallel to line M. That means they will intersect at any point. Let us say at point R. Now points P, Q and R are non-collinear, so we get triangle PQR. 1. Angle APQ plus angle RPQ is equal to 180 degrees as they are linear pairs. 2. Angle RPQ plus angle PQR plus angle PRQ is equal to 180 degrees, as the sum of 3 angles of a triangle is 180 degrees. From 1 and 2, angle APQ plus angle RPQ will be equal to angle RPQ plus angle PQR plus angle PRQ. As right-hand side of 2 equations are same, so the left-hand side. This implies angle APQ is equal to angle PQR plus angle PRQ. Therefore, angle APQ is greater than angle PQR. That is, angle APQ is greater than angle PQD, as point D lies on the line QR, but it contradicts the given angle APQ is congruent to angle PQD. So our assumption is wrong. Therefore, line L is parallel to line M. Therefore, if a pair of alternate angles formed by a transversal of 2 coplanar lines is congruent, then the lines are parallel. Theorem 1.3. If a pair of corresponding angles formed by a transversal of 2 coplanar lines are congruent, then the lines are parallel. This theorem is also known as corresponding angle test. It is given that line EF is transversal of two coplanar lines L and M, and angle EPB is congruent to angle PQD. We have to prove that line L is parallel to line M. Proof. It is given that angle EPB is equal to angle PQD. Let us consider this as statement 1. But angle EPB is equal to angle APQ as they are vertically opposite angles. Consider this as statement 2. Therefore, from statements 1 and 2, angle APQ is equal to angle PQD, which are alternate angles. Thus, from alternate angle test, line L is parallel to line M. Therefore, if a pair of corresponding angles formed by a transversal of two coplanar lines are congruent, then the lines are parallel. Theorem 1.4. If a pair of interior angles formed by a transversal of two coplanar lines is supplementary, then the lines are parallel. It is given that line EF is a transversal of two coplanar lines L and M, and the measure of angle APQ plus measure of angle PQC is 180 degrees. We have to prove that line L is parallel to line M. Proof. It is given that angle APQ plus angle PQC is 180 degrees. Let us consider this as statement 1. Angle PQC plus angle PQD is 180 degrees as they are linear pair. Let us consider this as statement 2. From statements 1 and 2, angle APQ plus angle PQC will be equal to angle PQC plus angle PQD. This implies angle APQ is equal to angle PQD. As it is satisfying alternate angle test, therefore line L is parallel to line M. Therefore, if a pair of interior angles formed by a transversal of two coplanar lines is supplementary, then the lines are parallel. Theorem 1.5. If the two lines are parallel, then alternate angles formed by a transversal are congruent. It is called as the converse of the alternate angle test. It is given that line L is parallel to line M. Transversal EF intersects them in points P and Q respectively. We have to prove that angle APQ is congruent to angle PQD. Proof. Suppose angle APQ is not congruent to angle PQD. Then, according to alternate angle test, draw a line N passing through point P such that angle MPQ is congruent to angle PQD. According to the alternate angle test, line N is parallel to line M. But it is given that line L is parallel to line M. This implies that there are two parallel lines parallel to line M passing through the same point P, which is outside the line M. This is contradictory to the uniqueness of the parallel lines. Therefore, our assumption is wrong. Thus, angle APQ is congruent to angle PQD. Therefore, if the two lines are parallel, then alternate angles formed by a transversal are congruent. Theorem 1.6. If the two lines are parallel, then the corresponding angles formed by a transversal are congruent. It is called as the converse of corresponding angles test. It is given that line L is parallel to line M. Line EF is the transversal. We have to prove that angle EPB is equal to angle PQD. Proof. It is given that line L is parallel to line M. Therefore, angle APQ is equal to angle PQD as they are alternate angles. Let us consider this as statement 1. But angle APQ is equal to angle EPB as they are vertically opposite angles. Let us consider this as statement 2. From 1 and 2, angle EPB is equal to angle PQD. Therefore, if the two lines are parallel, then the corresponding angles formed by a transversal are congruent. Theorem 1.7. If two lines are parallel, then the interior angles formed by a transversal are supplementary. It is called as the converse of interior angles test. It is given that line L is parallel to the line M. Line EF is the transversal. We have to prove that angle BPQ plus angle PQD is equal to 180 degrees. Proof. It is given that line L is parallel to line M. Angle APQ is equal to angle PQD as they are alternate angles. Let us consider this as statement 1. But angle BPQ plus angle APQ is equal to 180 degrees as they are angles in linear pair. Let us consider this as statement 2. But angle APQ is congruent to angle PQD. Therefore, from statements 1 and 2, we get angle BPQ plus angle PQD is equal to 180 degrees. Therefore, if two lines are parallel, then the interior angles formed by a transversal are supplementary. Properties of corresponding, alternate and interior angles. When a line intersects two coplanar lines, one pair of corresponding angles is congruent, then all the pairs of corresponding angles are congruent. 2. One pair of alternate angles is congruent, then all the pairs of alternate angles are congruent. 3. One pair of interior angles is supplementary, then the other pair of interior angles is also supplementary. 4. When two lines are parallel and a transversal intersects, then A. A pair of corresponding angles is congruent. B. A pair of alternate angles is congruent. C. A pair of interior angles is supplementary. That is, if any one of the statements A or B or C is given, then the remaining two statements can be proved. Let us solve some of the questions from exercise 1.4. Question 1. In the figure, line L is parallel to line M and line P is the transversal. If R is equal to 20 degrees, then find the ratio of A and B. Solution. As A is vertically opposite to R, A will be equal to R. That means A is equal to R is equal to 20 degrees. As A and B are a pair of interior angles, they are supplementary. Thus, A plus B will be equal to 180 degrees. This implies that B is equal to 180 degrees minus A. Therefore, B is equal to 180 degrees minus 20 degrees, which is equal to 160 degrees. Now, A upon B will be 20 degrees upon 160 degrees, which is equal to 1 upon 8. Therefore, the ratio of A and B is equal to 1:8. Question 2. In the figure, line L is parallel to line M and PQ is the transversal. If angle PEB is equal to 70 degrees, find the measure of each of the remaining angles. Solution. It is given that angle PEB is equal to 70 degrees. Angle PEB is vertically opposite to angle AEF. So, angle AEF is equal to angle PEB is equal to 70 degrees. Now, angle EFD is corresponding to angle PEB, so they are equal. Thus, angle EFD is equal to angle PEB is equal to 70 degrees. Again, angle CFQ is vertically opposite to the angle EFD, so they are equal. Thus, angle CFQ is equal to angle EFD is equal to 70 degrees. Angle PEA is in linear pair with angle PEB. So, angle PEA plus angle PEB will be equal to 180 degrees. This means angle PEA will be equal to 180 degrees minus angle PEB. So, angle PEA is equal to 180 degrees minus 70 degrees. Thus, angle PEA is equal to 110 degrees. Now, angle BEF is vertically opposite to angle PEA, so they are equal. Thus, angle BEF is equal to angle PEA is equal to 110 degrees. Now, angle EFC is alternate angle to angle BEF, so they are equal. Thus, angle EFC is equal to angle BEF is equal to 110 degrees. Again, angle DFQ is vertically opposite to angle EFC, so they are equal. Thus, angle DFQ is equal to angle EFC is equal to 110 degrees. Thus, angle AEF is equal to angle PEB is equal to angle EFD is equal to angle CFQ is equal to 70 degrees, and angle AEP is equal to angle BEF is equal to angle EFC is equal to angle DFQ is equal to 110 degrees.